Hi everyone, welcome back. Let's take a look at number 1, which says convert the polar coordinates 93 and 51.7 degrees to Cartesian coordinates. So I drew my x and my y axis. I measured over 51.7 degrees and then I measured out a length of 93. Okay, so that's where the vector is. So if I draw a vertical line, that's going to form a right angle. And so now I have a right triangle. Well, the x-coordinate is just this length, and the y-coordinate is just this length. And so to find my x-coordinate, if I look at the right triangle, that's my adjacent side. I know the hypotenuse, I know the angle. So adjacent, hypotenuse, that's cosine. So cosine of 51.7 degrees is equal to adjacent over hypotenuse. And when I solve, I get x is 57.6394 feet, inches, meters, centimeters, whatever. Okay, to find y is the opposite side. We know the hypotenuse, opposite hypotenuse is sine. And when we solve for y, we get 72.9842 and so on units. Okay, number 2 wants us to, let's see, it says the hole locations for the steel plate below are to be programmed to a numerically controlled jig bore. The turntable on the bore requires that the holes be located by giving the angle theta of each hole and the distance r to each hole, as measured from the hole H. Let's see, convert the dimensions of each hole. Okay, so if I look at the bottom right one, so that's this hole. Well, from here I go to the right, so that'd be my x value, 9.697 inches. So go to the right this far and then go up 0.958 inches. So that would be my y value. So x and y. So now we need to find r. Well, I can use the Pythagorean theorem, a squared plus b squared is equal to c squared, or r squared. And I find that this is 9.7442 inches. I forgot my inches. Okay, so to find that angle, it says that, well, if we look at the right triangle, we know our x value, our y value, which is our opposite side and our adjacent side. Opposite, adjacent, we're going to use tangent. So tangent is equal to opposite over adjacent. Take the inverse tangent of both sides and we get 5.642 and so on degrees. Okay, so that takes care of this hole. Let's move on to this hole. Well, my x value would stay the same because these two holes are above one another. And so we come over 9.697 inches, but to get up to this hole, we need to go up the 0.958 inches and then go up 3.021 inches for a total of 3.979 inches. So plug this x and that y into the Pythagorean theorem and you get the hypotenuse, or that third side, is 10.428 inches. And then to find the angle, we do opposite over hypotenuse. So the opposite side, you'd add these two together for that 3.9 number. And then the adjacent side is 9.6. So take the inverse tangent of both sides and you get 22.310 and so on, degrees. Okay, going around, the next point would be this one. And so you're just going to keep doing the same thing. We did the Pythagorean theorem and tangent, Pythagorean theorem, tangent. And so we're going to keep doing those to find the magnitude and the angle. Well, this time our x value, we don't go all the way over to here, right? And so we go over this 1.468, and then we go over another 3.244, and then go over another 3.593 inches. So add those three numbers up, and you get the 8.305 number. Okay, so that takes care of x. Now to figure out y, well, it tells us what y is. We go up 5.528 inches. So plug those numbers into the Pythagorean theorem and tangent. And then for the middle one, we would just add these two numbers together to get our x value. The y value is just that number. So plug those into the Pythagorean theorem and also into tangent to get the magnitude and the angle. Okay, and keep going around. Our x value is just the 1.468. The y value is 5.528. And then do the Pythagorean theorem and tangent. Okay, so I don't know if you've picked up on this yet or not. It might be too early. But in this lesson, all we're going to do is we're going to start with an x and y value and use the Pythagorean theorem and tangent to find the magnitude and angle. Or we're going to be given the magnitude and the angle, and we need to find our x and y coordinates. So we're either going to use cosine or sine to find those. And that's all we're doing in this section. So nice, easy section. I would say this problem here is the most challenging simply because there's so many little parts to it. But anyway, let's pause the video there because I'm sure the video is getting way too long, and we'll come back and look at the rest of the problems.